Okay, now let's move on to the next part, that is question number 71 of the same paper code, that is code number D. So the question says, the major product obtained in the following reaction is, so you have been given a particular reactant. So if you could see here, there is a halogen atom, and if you could see here, there is an adjacent hydrogen itself, right? So this could give you a feeling what exactly is going to happen over here, but there are certain obvious distractors which are there in this question, which may take you to a wrong answer. Right? So let's see what exactly it is. So if you could see the reagent is basically potassium tertiary butoxide. So let's try to write down the structure of potassium tertiary butoxide. So tertiary, that means it has to have a tertiary carbon, correct? So you have a CH3 over here and you have a CH3 over here, correct? And then there is O minus and there is K plus. So if you could see here, this is a very strong base or a nucleophile, that's what you could say, because this has 3 +I groups which are donating electrons to the carbon, thereby increasing the negative charge on oxygen. So it's a very strong base. So what exactly would be the function of a strong base? So the function of a strong base would be to abstract a proton. Right? So the proton which is attached over here could not be abstracted because the approach of the nucleophile would be retarded due to the presence of Br over here. So it undergoes a beta elimination, as a result of which this hydrogen would be abstracted. So what would happen? This hydrogen would be abstracted, and then hydrogen would be giving the electrons to the carbon, right? And bromine would be acting as a leaving group. So the ultimate result is basically dehydrohalogenation, correct? When H is removed and Br is removed, so they form HBr, right? So what exactly would happen over here? So let me write the final structure. So you have C6H5 over here, correct? And then you have one bond, you have another C6H5 over here, and there is a double bond, right? So if you could see here, this is chiral, correct? So this is chiral, but this is not chiral anyway. This is chiral compound, but the result is basically achiral, correct? So this is basically the final product which you are expected to get here, and the name of this reaction is basically dehydrohalogenation, or I would simply say this is nothing but an elimination reaction. So this is basically a beta hydrogen elimination reaction. So let's have a look what is going to happen over here. So here Br would be acting as a very good leaving group because bromine needs just one electron to become stable. So the moment it gets the extra electron, its octet becomes complete, right? So it's a very good leaving group. So if you could see here, the first option, so this is achiral, so you can just neglect all these three, right? So this is going to be the correct answer. So option 1 is the correct answer. Now, in the beginning of the question, I said that there is something distractor in this particular question, right? So one may just make a mistake saying that this is a nucleophile. So this is nothing but an SN1, SN2 type of reaction, and may try to analyze the question saying that this would follow a carbocation mechanism, as a result of which the carbocation would be generated here, correct? Carbocation would be generated here, and then Br minus would be substituted by this OTBU minus, right? As a result of which, so this basically deals with carbocation mechanism. If you are going to just do the mistake of getting this like an SN1 pathway, right? So what could be the mistake which you might have been, which most of you might have been done, is that you might have misunderstood this reaction as an SN1 reaction. In SN1 reaction, the front side attack and back side attack takes place in equal ratio, as a result of which you get a racemic mixture. So this is basically the obvious distractor which you might come across in this particular question. But if you know that this is a very strong base, so strong base would undergo dehydrohalogenation rather than substitution reaction. So the correct answer to this question is option number 1.